Now, this is a great question that A-level math students always ask me every year. Why are some of the graph transformations the opposite of what you think they would be? So as a good example, why is it true that f of 2x actually squishes in the original f of x graph by a factor of a half? Surely it would stretch it out by a factor of 2 in the x direction, not squish it in by a half. And again, same thing with this one here. When you've got f of x plus 2, you actually shift the graph to the left by 2, not to the right. So why is that? So to answer the question, we need to go back to basics a little bit and just think about what it means for y to be equal to f of x. So if we go back to Key Stage 3 or GCSE, you would have seen these function machines. And the idea is that we've got some x values on the x-axis, and we're going to plug in all these x values on the x-axis into this machine. So again, we take some random values like this one here, we plug it inside the machine, and we're going to get an output. Now, every machine or every function has a range of outputs. So obviously for a fixed set of x values on the x-axis, when you plug them into the machine, you're going to get a set of outputs, the range, a minimum value and a maximum value. And these are our y values on the y-axis. Now, I do just want to re-emphasize that every machine has its minimum and maximum, right? So different functions, different machines will have different minimums and different maximums. So this machine here has a minimum of whatever this is and a maximum of whatever this is. So what I'm going to do now, I'm going to take this x value that I used before. I'm just going to call this the old x coordinate. So I plug in this old x value into the machine. And let's just say, for argument's sake, that the machine will give me whatever this value is here. So I'll call this the old y value, the old x value into the machine, substitute that into the function, you get out something called the old y value. So what I'm going to do now, I'm going to double all of these x values on the x-axis. So I've tried to double this number line from before, and I'm going to call this number on the x-axis 2 times the old one. So I've kind of tried to scale it up. So double that, you kind of get something there. I'll just label the old x value there to keep it consistent. Now we're going to keep exactly the same machine as before, right? This is exactly the same function, exactly the same machine. Now, because it's the same machine as before, both the minimum and the maximum possible outputs from that machine do not change, right? A machine cannot go lower than its minimum and bigger than its maximum. So it's still exactly the same range as before. Nothing has changed in terms of the outputs. Now I'm just going to call 2 times the old x value the new x value. And so this here is half of the new x value. So the question is, which number do I plug into my function to get the same old y value as before? In order to achieve that same output as before, I have to plug in, not this one, I have to plug in the same old x value, exactly the same x value as before, because it's the same machine. So what this is telling me is that I have to halve my new x values in order to get the same output as before. So basically what we've just done is we've taken a graph y equals f of 2x, and this x was our old x value. We've doubled it to get our new x value. So 2x is our new x value. And what we established in this diagram here is that we need to halve our new x values to get the same y values as we did before. And that's why f of 2x actually squishes in your graph and not pulls it out. So as an example, notice that if you have your old y value, we have to halve the x values to get the old y value. So that's why f of x plus a and f of ax do the opposite of what you think. However, y equals a times f of x and y equals f of x plus a do exactly as you would imagine, because with this one, we're multiplying the machine by a. We're actually taking this machine f and we're timesing it by a. With this one, we're adding a to the machine. So they're doing exactly as you would imagine, but these two are doing the opposite of what you would imagine. Hope that helps. I do have a free revision guide in the link in my bio on more graph transformations, including modulus graph transformations. Just click the link in my bio and you can get that free revision guide on graph transformations for free. Hope that helps out.